Alright, good day class. This is Physics with Eshemohai, and we are in Scalar and Vector Quantities. That's our week 2 topic, and we'll be talking about addition and subtraction of what? Vectors. Alright, before we continue, please write this down. Now, two or more vectors acting on a body in a given direction. Two or more vectors acting on a body in a given direction can be combined to give a single vector. Pen down. Two or more vectors acting on a body can be combined. Two or more vectors acting on a body in a given direction can be combined to give a single vector, which produces the same effect in what? Magnitude. Which produces the same effect in magnitude and direction as the original vector acting together. So that vector that you're talking about now is known as what? Resultant vector. Alright, now that is what we know as resultant vector. Now, for you guys to easily understand what resultant vector means, now for your easy and the way you can easily get what resultant vector is. Now, resultant vector, alright, these are single vectors, resultant vector are single vectors which have the same effect in both magnitude and direction. Resultant vectors are single vectors which has the same effect in both magnitude and direction. As the original vector acting together. So these are resultant vectors are single vectors which have the same effect in both magnitude and direction as the original vectors acting together. So that is resultant vector. Now let us now talk about, so we know we are under addition and subtraction of what? Vectors. Now under this one, let us say we have two vectors, let's say two forces. We have two forces acting on they are acting on the same direction. Now we have two forces acting on the same direction. Now we say we have two forces, that is F1 and F2. Follow me. Acting on the same direction. Are you following? Alright, on the same direction. Now we have two forces acting on the same direction. Let us say our F1 should be 30. F1 is equals to what? 30. F2 is what? 20. Let's say F1 is 30, F2 is 20. Alright, let us now. We said F1 and F2 are acting on the same direction. So we have two vectors, they are acting on the same direction. So if F1 and 30 is acting this way, that is 30 Newton. Then we have 20. Alright, now we have 20. Okay, now the question you should be asking now is what will be the symbol here? Is it going to be addition or is it going to be subtraction? Are you getting me here now? Is it going to be addition or is it going to be subtraction? So whenever two vectors are acting on the same direction, you add the two vectors. So we have a plus here. So we add the two vectors, giving us what? 30 plus 20 give us what? 50 Newton. Now we know now that when we have two vectors like this acting on the same direction is addition. Now let us now say we have two forces acting on opposite direction. Now we have two forces. Now F1 and F2 acting on what? Let's clean this and write opposite direction. Okay, all right. So the acting on opposite direction, we have a straight line. All right, get it? We have F1 30, we have 20. Now we want to know what will be here. What will be here when they are acting on opposite direction? It's a minus. So 30 minus 20 will give us 10. Alright. We have perpendicular vectors and we have non-perpendicular vectors. I repeat, we have perpendicular vectors, then we have non-perpendicular vectors. Now pen down. Whenever, see, now for you to know this thing is a perpendicular vector, now what you should know is that when F1 and F2 are inclined at a right angle to 90 degrees, whenever F1 and F2 are inclined at right angle to 90 degrees, it is what? A perpendicular vector. So for you to know an example of that, let's say here should be 8, here should be 6, 90 degrees. Now we get it. This is the 90 degree. Now if we want to solve for magnitude, we use Pythagoras theory. So for magnitude is what? Pythagoras theory. Pen down. Whenever first thing you must know is that F1 and F2, they are inclined at a right angle. Now they are inclined at a right angle. Yeah, at right angle 90 degree. Now that is the first thing you should know. Now you have gotten that they are inclined at right angle, that is 90 degree. 2, the next thing you should do is, are we looking for magnitude or are we looking for direction? Now if we are looking for magnitude, we use Pythagoras theory. Then if we are looking for direction, we use geometrical ratio. Alright, now let us say for Pythagoras theory, let us solve this. We have what? Arrow, that's our resultant, is equals to what? Square, then we have our F1 plus F2. Remember, 2. Now let's solve this. Arrow square is equals to what? Bracket 8 square plus what? 6 square. Are you getting me now? We are solving for this now for with Pythagoras theory. Alright, then arrow square is equals to what? 8 square is 64 plus 6 square is 36. Are you following me now? Now add the two of them together. We have what? Arrow square 64 plus 36. We have 0, carry 1, everything together will give us 100. Now we have 100. Square 100 giving us what? 10. So the answer for here when we are solving for magnitude is 10. But because of time, I'll give you the formula to solve for what? Direction. Now the formula is solving for direction. The formula for solving direction, the formula is what? We have tan A is equals to what? Opposite over adjacent. Now alright, now we have gotten this place. Now we'll say then from here the answer, instead of me to write this tan, is still equals to what? F1 over F2. Then we'll have A is equals to what? Tan inverse. Put this in your head. Is equals to F1 over F2 for direction. Are you getting me here? Now for direction. Alright, let's go into non-perpendicular vectors. Let's go into what? Non-perpendicular vector. Non-what? Perpendicular vector. That is the next one we enter now. Alright, for non-perpendicular, we use, now to obtain the magnitude, we use what? Cosine rule. Then for direction we use sine rule. So for magnitude we use cosine, for direction we use sine. Direction, magnitude. So we use direction. For that we use cosine rule for magnitude, direction for direction we use sine rule. So because of time, I'll give you the formulas. Then we'll call it, this way we'll stop for scalar and vector quantities before we go to other topics because of time. Maybe during the course of the our revision by next year, we'll try to talk on some topics we could not get to. Alright, let me give you the formula. Now, using cosine rule, when your angle is inclined as what? 45 degrees. When your angle is inclined at 45 degrees, the formula is, put this in your head, we have r square equals to f1 square plus f2 square is f1 square plus f2 square is equals to 2f1 f2 cos what? 180 theta. Cos 180 theta. Now that is for using cosine rule. Where we are getting the direction. Now that is when it's inclined at 45 degrees. Now another heading, right? Using sine rule, the direction is given by. Using sine rule, the direction is given by. That's another line. The direction is given by. For sine rule, the formula is what? Sine A over O A sine theta over. Alright, now this is for direction when the angle is inclined at 45 degrees. Now let's go if f1 and f2 is inclined at 60 degrees to each other. 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 The same cosine and sine rule. Now the formula will be r square. R square is equals to f1 square plus f2 square minus 2f1 f2 cos bracket 180, sorry, let me write it be 180 minus theta, cos bracket 180 minus theta. Now let's go for direction. Your direction, we have sine A over what? f1 is equals to sine theta over what? r. Alright, now let's write if it is 120. If it is 120 degree, you remember if our angle is inclined at 120 degree, it's just the same thing in the cosine rule. First, we have r square is equals to f1 square plus f2 square minus 2f1 f2 sine cos bracket 180 minus theta. Your theta remains what? That number. If it's inclined at 60, your theta is 60. If it's inclined at 45, your theta is 45. If it's inclined at 120, your theta is 120. Now for direction, that is what we we'll call it a day. For direction, our sine is what? Sine A is equals to sine theta x times what? Sorry, sine theta over what? Alright. Now, in case you are confused that what does this AOA mean? What does this OC mean? Now, before I round up, this is what I will end with. OA means what? OA is what? Your F1. OA is your F1, then OC is your resultant. OC is your resultant. So OA is your F1, OC is your resultant. Wherever I wrote plus, remember, put minus. So this is what we call it for a day for scalar and vector quantity. Don't forget to subscribe to my YouTube channel, and also those watching from Facebook, thumbs up for all of you. Don't forget to follow. For special WhatsApp classes, don't forget to contact me on 08024072621. I still remind you of your favorite tutor, Shemohai and Mozozo. Alright, this is understanding science. Remember, understanding science made easy. See you guys next time.